Okay, for real this time. A little over a year ago, I posted a video covering a LEGO vacuum engine that I built utilizing Walschaerts valve gear. Since then, I've gotten a few requests to do a tutorial on how to build one. So, here I am in the basement at the LEGO table. Now, this isn't going to be a tutorial where I show you every single part that you need to replicate my design exactly. My goal is to show you how to make the basics and how to design an engine on your own, how to modify my design, and give you a basic understanding of how everything works. For those of you who do not know what a LEGO vacuum engine is, it is an engine made out of Legos which runs on a vacuum. Mind-blowing, right? Unfortunately, I do not have that engine anymore. It has been deconstructed and reconstructed into this. This is an inline 4 Maybe I'll make a tutorial on this engine in the future too. No, no. Oh, come on. I forgot. I made the worst mistake while designing this engine. Look at that. That might as well be a crime. Okay. First part to make is the cylinder. To start, I have a 6x6 plate, 2 1x2 plates, and one 1x4 plate. And I'm just going to put these together with the 1x2's one stud in from the edges and the 1x4 on the end like that. Now, I'm going to build a 1 block tall perimeter all the way around this shape. None of these bricks have to be in any particular spot, but I would say that you should have a 1x4 here with 2 pieces on the ends, since it'll be more stable when we put our panel on. Now, with a 1 brick perimeter, we're going to put a 1x1 brick on one of these studs here and leave that gap for air to flow through. Next, we need 2 of these 6x1x5 panel pieces. You don't need these, but it makes it a whole lot easier, and it decreases friction because the piston doesn't have to go over any seams between bricks. So we're going to put these on here and on here. And now, for this area, you could just fill it with 1x4 bricks, but again, that increases the friction, so I'm just going to use these 1x2x5 panels. Now, we're going to build this up here by 2 layers, and we're going to cover this so we don't have any gaps in these 2 layers here. Now that we have gone 2 layers up, we're going to do another layer, but this one is going to have a gap on the outside here. So we're going to leave it open right here. We're going to leave a 1x2 gap right there. And of course, we left that 1x1 gap in the bottom layer. So now we're going to do another 2 layers. Okay, we should now be level with these panel pieces. Now we're going to do another perimeter layer, just the outer perimeter. And after we do just the perimeter, we are again going to put a 1x2 in there. So as you can see, we have this hole in the center, and then a 1x1 hole on either end. And now, we're going to move on to the top piece. Before we put the cover onto the cylinder, we need to put the piston down inside. So for that, I have a 4x4 plate. I'm just going to put this 2x2 round brick. Since it has the hole for the axle needs to be long enough that it can sit down inside while still peeking out of the top just a bit. This one is 9 studs long, and And now all you have to do is put that down on there, and then put this down inside. Okay, for the top, first thing, 1x4 on the end, and 2 1x2s, just like on the bottom layer right here. Those. For this piece, I'm going to take a 4x4 circle with that hole in the center, and we're going to take 4 2x4 plates, and we're going to put them around the edge like this, so that what we have at the end is a 6x6 piece with the hole in the center, and then that can go right on top of there. And now what we have is a cylinder with the piston inside, just like that. For the valve, you need 2 2x2 bricks, 1 1x1 cylinder brick, 4 1x1 normal bricks, 1 4x4 cylinder brick with the axle hole in the middle, some sort of connection to that brick. Here I have a pin to axle connection. I can just put this 2 stud long axle in and put it into here, and I can connect that to a connecting rod. To start, we need the 2x2, and because the 1x1 square pieces cannot fit in between the studs, you need the cylinder one first to fit down in there. Then you can stack the 4 other 1x1s and put them on top of that. Then put the other 2x2 on top. Make sure they are not crooked in any way. And then you can put the cylinder on top. And that can slide into here. Okay, so now with the cylinder, valve, and piston done, put that off to the side and start making the base. This is where things start to get a little arbitrary, where you can tweak things. It doesn't need to be exactly the same, but the goal is to just have a long plate so that we can have our cylinder, have our crankshaft, and have some gap in between for the valve gear itself. Here is what I have for now. You can always change it later. To attach the cylinder to the base, I just have a snot brick here on the back with 2 1x4 plates. And on the front, I have 2 1x2 bricks with axle holes. And the holes need to be aligned with the studs. And now we can just put this down on here, and it lines up perfectly. And now we have our piston mounted. Now for the crankshaft, we have 2 of these 3 stud long, I guess, axle connections into one of those. We put a 3 stud long axle, then we put our connector, then we put the other arm, bar, whatever you want to call it. Then we put a 2 stud long axle, then a 2 stud long pin to axle connection goes on here, 90 degrees offset from the other 2. To attach crankshaft, I have this 1x6 brick with holes on 2 layers of bricks. I'm just going to put this down at the end. Now I have this 6 stud long axle with a half brick long stopper. I'm just going to attach that to the crankshaft and then put it in this brick here. And now we have our crankshaft, and you want to make sure that this center piece is lined up with the center of the cylinder. Okay, I've just modified a bit to add this little platform here so that I can have another connection point for the axle so that it's not as loose. I've also swapped out that 6 stud axle to connect the piston to the crankshaft. I'm going to use these parts here. This is where it starts getting more arbitrary, where you can really start doing your own thing, figuring it out yourself, because I doubt everyone's going to have the same types of parts. Onto the end of the piston, I'm going to put this piece axle connection here, axle connection here. Put that onto there. Into that axle connection, I'm going to put a 2-stud long axle. And onto the end of that, I'm going to put this piece, 2-stud long axle to pin connection there. Now, in this little corner here is where we're going to put our connection, which will connect to the crankshaft. But we also are going to need a connection to the valve gear up top. So I have this 3-stud long pin. I'm going to put that onto here and then onto the end of the piston like that. So now we have a low friction connection here, which will connect to the crankshaft. And we also have this pin that comes off to the side, which will connect to all the valve gear that we are going to put in. Okay, now to connect these two ends, I have a few axles here, and I'm just going to see which ones work. To do this, I have the crankshaft at the central position, and the piston is central in the cylinder. So now I can start laying out pieces to see which ones are the right length to connect the two pieces together. And that looks pretty good right there. This looks like an 8-stud axle with a 6-stud axle, and I'm just going to put them into this connector here. And then connect the two ends here and here. And now we have the piston connected to the crankshaft, as you can see. And it looks like it is a little too short. Okay, I found a better combination. 8-stud axle with 7-stud axle, and as you can see now, the piston goes the same distance nearly at either end of its stroke. So now we can start working on the valve gear. Okay, now to make the expansion link, which is the arm with the groove down the center of it, I have 5 1x1s stacked together, 2 1x1s, 1 1x2 with a hole, and then another 2 1x1s, a 1x3, and a 1x4 with axle holes. And we are going to put these 2 stacks of 1x1s underneath the 1x3, and then we're going to put the 1x4 underneath all of that. Now we have this, and then to slide up and down in here, we will have this 1x1 brick with an axle hole in it. To find where the expansion link should go, you'll want to pull the piston out to its furthest point and make sure that this link doesn't hit the pin right here when it comes out all the way. So for me, it looks like it can go right about there. But we're going to have it raised up so that this hole here is about the same height as the valve. Okay, as you can see, I've built up a little structure here in order to hold everything on top. It doesn't need to be in the exact same spot if you're building it. It just needs to be around the area that your link should go. I now have this structure on here. These holes and these bricks here, tried to get close to the same height as this connection on the valve. The expansion link will be attached to one of those holes. I now have the expansion link attached on this 7-stud axle with some stoppers such that it lines up with this end piece on the crankshaft and is at the right distance, but it won't get hit by this pin at its furthest point. Next is the eccentric rod, which connects the crankshaft to the expansion link. And for that, I have this bar right here. It is an 8-stud axle connected to a 2-stud axle with these pin connectors at either end. And the goal here is to just connect the center hole on the link to the crankshaft. There we go. So now, as you can see, the link is nearly vertical here, when the crankshaft is nearly vertical, which is exactly what we want. Okay, next order of business is the combination lever, which connects the piston, the valve, and the radius rod together. Now for that I have this 7-stud arm, and I'm going to put this low friction pin 2 holes from the end. See those 2 empty holes, and then we have our pin. We're going to put this into the valve like that. Now to connect the piston to the combination lever, I have these 2 connectors which are connected by this 2-stud axle. I'm going to put this low friction pin into one side. We're going to put it onto here, just like this. Now for the radius rod, I have this 9-stud arm connected to the 7-stud arm like this. Onto the longer end, I'm going to put this pin. Onto this end, I will put this 3-stud pin with the 1x1 brick with the hole. Now this will connect into here. You want to make sure that this 1x1 is upside down when it slides into here. And then the pin on this side will attach to this red arm, the combination lever, 1 stud below where the valve is attached. And then I'm going to put this wheel on the end of this pin here to make sure it doesn't fall out. Hello, it is the next day, and as you might be able to tell, I've made a few modifications to the engine. First of all, the expansion link was moved over 1 stud to the right, and to do this I shortened the eccentric rod by 1 stud, and I lengthened the radius rod by 1 stud. And speaking of the radius rod, I have changed it quite a bit. Rather than being the 2 straight bars snapped together, there's now an L bar and a straight bar, since the bar was having trouble interfering with the pin up here. For the valve, I replaced the cylindrical brick with 2 cylindrical plates so that the connection would be shorter. The 2 connections on the combination link were moved up by 1 hole each. So as you can see, there's only 1 empty hole, and then we have our 2 connections. I also added this control arm for the radius rod to move it up and down the expansion link. Now on the engine that I made originally, I had a set of gears controlling this arm, but for this one I opted to just use a high friction pin to hold the arm in place. Now the final part, of course, is the flywheel, and this flywheel is actually pretty simple. It's a bunch of 2 stud wide plates which have been layered together, and in the center I have 2 of these plates with holes, and right in between them I have this circular plate which has the axle hole in the middle, and then on each end I have 1 2x4 brick to act as weights to give the flywheel some inertia. And now the final piece I made was also this adapter which sits on top of the inlet right here, so that my vacuum can fit onto it perfectly, like that. I had to slightly lengthen this connection by pulling out the connector just a bit, but other than that, it should be pretty good. Now before I run this engine, I want to say thank you for watching. If you have any questions, please leave them in the comments, and I will answer it to the best of my ability. So now with that, let's go run this thing.